Illustrative Math, Algebra 2, Unit 6, Lesson 10 is called Beyond 2 pi. All right, our goal today is I understand how to find the values of cosine and sine for inputs greater than 2 pi radians. All right, our warm-up. Here's a unit circle with point A marked at 1, 0. For each angle of rotation listed here, mark the new location of A on the unit circle. Be prepared to explain your reasoning. Okay, so first of all, I want to make sure that we understand here what these marked angles are here. So if I look at this semicircle, okay, if I divide it into 4 equal sections, each sector or slice of the pie is pi over 4. So this is 1 pi over 4, and then this is 1 pi over 4. So this angle would be 2 pi over 4 right here. And then this is 1, 2, 3 pi over 4. So this angle is 3 pi over 4. And then right here, this angle would be 4 pi over 4, which is pi. Okay. So I guess to maybe start things out, maybe I could do this one first, number 3, because I know I go by pi over 4. So 1, 2, 3, 4, 5, 6, 7 pi over 4 would be right here. Okay. So this would be number 3. This would be my A. Or I guess, I'm going to call it point D. I'm sorry. This would be point D. That would be easy to do first. Now, the next one that might be easy would be the pi over 2. So maybe I'll do those next. So my pi over 2, again, it's kind of like I take my half a circle, my semicircle. If I cut it into 2 equal pieces, this is pi over 2. Okay, so 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So right here, this point is my point E, because I went 1, 2, 3, 4, 5 pi over 2s, okay? So there's that one. 6 pi over 2 would be one more right here, so that's 6 pi over 2. That would be F. Okay, so now let's go to the pi over 3. So here's what I'm going to do. I'm going to erase this circle here. Oops, I erased my points. F, E. Okay, so pi over 3, again, it's like I'm taking this half circle and I'm cutting them into thirds. So here's what I'm going to do. They didn't mark this, but I'm going to kind of erase these lines here. Oh, shoot. I didn't want to do that. So I'm going to erase these lines, and I'm going to cut my circle into equal sections here so I can help see it a little bit better. So I'm cutting it into 3 equal slices. Okay, so now each one of these is pi over 3. Okay, so this would be here pi over 3. So this would be 2 pi over 3, 3 pi over 3, and then it'd kind of be the same thing if I just kind of extend this line, not that one. If I extend this line here, back, it should be the same line. My picture's a lot. There we go. So right there would be 1, 2, 3, 4 pi over 3. So right about there would be my C, my 4 pi over 3. Oh, I guess I should have put my B up here. This would be my B. This is 1 pi over 3. Okay? All right. Give us a nice little picture here of a windmill. It says the center of a windmill is at 0, 0, and it has 5 blades, each 1 meter in length. A point P is at the end of the blade that is pointing directly to the right of the center. Here are the graphs showing the horizontal and vertical distances of point P relative to the center of the windmill as the blade rotates counterclockwise. All right, let me, I'm going to kind of adjust this here. I'm going to put a circle right there. So there's my There's my circle. And then this is at 0, 0. So I'm going to draw a line right through there. Okay, up at the top here, it's going to be at 1, 0. Or 0, 1, I should say. Sorry. This was here at 1, 0. This here is at -1, 0. And then this down here is 0, -1. Okay, so how many full rotations are shown on the graph? So it's like we start here at 0. So this is horizontal distance. So I start at 1, which is why I start up there. And then at pi over 2, I'm at 0. So that would be right there. And then I go to pi, I'm at -1. We're looking at the x coordinate. That's the horizontal distance. And then 3 pi over 2 would be down here. That's at 0 again. And then 2 pi, we're back to the start. So really, that's a full cycle of the windmill. Okay, picture it like this here too. I guess maybe I should have done this earlier. Here's my windmill blade. So it starts right there, it goes around, and boom, we're back at 1 up here. Okay, and then I go again. So it's like it's almost like, here's a full cycle. And then I'll change colors, and there's another full cycle. And then we end at -1, so it ends right here. So it's almost like it's 2.5 full rotations. So I'm going to say 2.5 rotations. What are the values of the graphs at theta equals 3 pi mean in this context? Oh, I guess I should have done this one too. This is going to be the same thing. It just starts at 0. So it's kind of the same idea here. There's a full rotation. Get back to where you started. There's another rotation back to where we started. And there's my half. So what are the values of theta at 3 pi mean? Okay, so 3 pi is right here. This would be right here. 3 pi is -1. So that would mean that the horizontal distance is -1. And then over here at 3 pi, it's at 0. So this would mean the vertical distance equals 0. Okay. There's some different angles of rotation that bring P to the highest point in the circle rotation. So the highest point's up here at pi over 2. But you could, there's pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2s. Every time you cross an axis, it's rotating pi over 2. And then if I keep rotating here, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2. And then you could basically keep on adding pi over 2, right? So really, technically, if you wanted to get technical, you could say pi over 2 plus any multiple of 2 pi. So I'm going to say 2 pi times some number, okay, would technically be the best way to write it, where n is a whole number, n is an integer technically. I'm going to say n is any integer, okay, because you want to have whole number multiples of pi. So you just keep adding 2 pi, or you could go, technically go the other direction, and those are going to be negative as well. All right, which we'll learn about that later. How many angles show point P at a height of 0.71 meters? Explain or show your reasoning. So, I could look at my windmill picture here, or I could just go to my graph. The vertical height is this graph here, the sine graph. So 0.71 would be like, I don't know, maybe like right there. Maybe a little lower. Move that down just a little. All right, so, obviously it keeps repeating. So there to there. So twice on the first cycle. And then, twice on the second cycle. And then twice on the third, or the third half cycle. Okay, so technically we would say infinitely many, but 2 per rotation. Okay. All right, the point P on the unit circle has coordinates 1, 0 right there. For each angle of rotation, state the number of rotations defined by the angle and then identify the coordinates of P after the given rotation. So they started out with us here, 3 pi over 2. So that would be, your rotation would look like this right there. Pi over 2, 2 pi over 2, 3 pi over 2. So you did 3 pi over 2 is your rotation. So I did 0.75 of a full rotation. Okay. Full rotations. I did 3/4 of a full rotation. This has a horizontal coordinate of 0, vertical coordinate of -1. All right, next one, 25 pi over 12. So remember, this is pi radians. So in other words, it's 12 pi over 12. It's like if I took this half circle, cut it into 12 equal slices, and then over here, this is 2 pi. So 2 pi would be like kind of like 24 pi over 12. So it's like if I had 12 more slices down here, be like 1, 2, 3, 4, 5, 6 equal slices, 12 in each one, 12 in each half of the circle. And then so I really need to go an extra pi over 12 right here, okay? So I went 1 and then 1/24. So 1 and 1/24 because I really have 12 and 12, 24 slices in the full circle, or 24 sectors. So the horizontal coordinate is going to be the cosine of 25 pi over 12. Or you could really, I don't really have enough room on here. Let's do this. I'll come over here. So this is going to be the cosine of 25 pi over 12, or you could say the cosine of 1 pi over 12. You should get the same number. Now, when I put this into my calculator, I'm going to make sure I'm in radian mode. So I'm going to say cosine of pi over 12. Whoops, I was in degree mode as I say that. So I get 0.96. The vertical would be the sine. So the vertical would be the sine of 25 pi over 12, or the sine of pi over 12. Should get the same answer either way. So the sine of pi over 12 gives me 0.26. And remember, those numbers squared added together should equal 1. All right, the next one here says 5 pi over 2. That one's pretty easy because it's a pi over 2 multiple. So here start at 0, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So that one is 1 1/4 rotations. All right, and this one I can do very easily. The horizontal coordinate is 0, the vertical coordinate's 1 because it's at the top. Next one, 7 pi over 3. So pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3. So that'd be 1. Well, let me use a different color here. That'd be 1 and 1/6. So this is at pi over 3. So here, for that one, you could say cosine of 7 pi over 3, or you could say cosine of pi over 3. Should get the same number here. Type it in my calculator, and I get 0.5. And then the vertical would be the sine, so sine of 7 pi over 3, or the sine of pi over 3. And I get 0.87. All right, 49 pi over 12. Whoa. So 12 pi over 12, 24 pi over 12, 36 pi over 12, 48 pi over 12. I had to go one extra pi over 12. So it looks like I went around 2 and 1/24 of a circle. And really, I'm at the same spot that I was here. So you could type in cosine of 49 pi over 12. It's the same as typing in cosine of 25 pi over 12, which is the same as typing in the cosine of pi over 12. So you can get the same answer that I had up there when I had it in purple. So there you go. All right. And then the last one, 5 pi. So pi is 180. So pi, 2 pi, 3 pi, 4 pi, 5 pi ends right there. So that one is going to be, let's see here, I went 1, 2, 3, 2.5 rotations. And the horizontal coordinate's -1 and the vertical coordinate 0. So in general, if theta is greater than 2 pi radians, explain how you can use the unit circle to make sense of cosine theta, sine theta. So I would just say you could subtract 2 pi as many times as needed until the angle is between 0 and 2 pi. Okay, so like for instance here, this 5 pi, we ended it right here. It's kind of the same as saying, okay, well, 5 pi minus 2 pi, that's going to be 3 pi. I minus 2 pi again, I get to pi. So these are in the same exact spot on the unit circle. So this is a little bit easier, so we don't have to go around the circle a bunch of times. Okay. All right, point A is the result of rotating point P counterclockwise pi over 2 radians. It's also the result of rotating point P counterclockwise by 5 pi over 2 radians. Okay, so again, I'll show you this here. So here's my pi over 2 rotation. Here's my 5 pi over 2 rotation. How is the point pi over 2, 0, 5 pi over 2, 0 related to point A? I would say this is 1/4 of a rotation, a full rotation of the circle. We only went 1/4 of the circle. This would be 1 and 1/4 rotations. Okay, they are in the same spot though. So I would say here also these are in, the same place, which is where A is. Which point on the circle corresponds to 3 pi over 2, 0? So your angle is 3 pi over 2. So 1, 2, 3 pi over 2. Okay, so 3 pi over 2, that would be right here. Okay. So the last one, how can you tell that cosine of theta is equal to cosine of theta plus 2 pi for any angle theta? I would say if you add 2 pi to theta, you will just do one more rotation, which puts the point in the same spot or same place. Okay. All right, point A is 0 radians, is at 0 radians with coordinate 1, 0 on the unit circle. Point B is the result of point A rotating 7 pi over 6 radians counterclockwise around the unit circle. Name 2 other positive angles of rotation that take A to B. So really, you could just add 2 pi or subtract 2 pi, or, so if I add that there, 2 pi is really, if you wanted to use the common denominator, this would really be 7 pi over 6 plus 12 pi over 6 is the same as 2 pi. So that would give me 19 pi over 6. Do not type the pi button into your calculator. Just treat this as regular like terms. Like if I had an equation, 7 over 6x plus 2x equals whatever, you would just add the coefficients and put the x next to it. Same idea here. Just add them together and put the pi next to it. If I added another 2 pi to that, I'd still be in the same place. So, or you could just add 12 pi over 6. You're going to get 31 pi over 6. So you could just keep adding 2 pi if I wanted to keep finding more angles. Those are actually called coterminal angles, okay? Coterminal angles, okay? They're angles that are in the same position on the unit circle, but they're different angles. All right, well, hopefully you guys enjoyed this video. Thanks for watching, and we'll see you next time.